Well, hello and welcome to Modeling with Polynomial Functions. Yeah. So what I've done, I've got an example here. I'm just going to walk you through it, and this is kind of going to be our one and only example, I think. And it says, use a 70 centimeter by 40 centimeter rectangular cardboard. So that's what this is here. This big rectangular piece is the cardboard. And we're going to make a box. And what we're going to do is we're essentially cutting out these little squares here. See these little squares in the corner? We're going to cut all these out. And they're all going to be the same size. Just going to cut out these little squares. And then we're going to fold these tabs. There's 4 of them. We're going to fold them up on the dotted lines. And then we're going to tape the outside. And guess what? We're going to have a box, a 3-dimensional box. And we're going to try to maximize the volume. So in the end, let me just show you roughly what the box might look like. I'll do a mini version of it here. Okay, it would look something like this. Oops, pen slipping all over the place. Anyway, this is roughly what our little box would look like. Okay, and you got a little bit of tape around here to hold the corners together because you're just going to fold them up thusly, right? Just fold them in like this, and then voila, a handy-dandy little box. Okay, so what are the dimensions of the box? And we would really like to try to maximize the volume. Well, the long side here is 70 centimeters, and we don't know how big to make these little squares, so we're going to make these x by x. And all these little squares have to be the same size, otherwise our box will look funny. And the only other thing that I know is that this complete distance down this way is 40. So if I go up to my little box here, what I know is that the height of the box, I guess, is the same as this distance here. Okay, because this is the part that folds up, right? So this side here is okay, that's the height of the box. And then along this side here, this looks like the narrower side the way I drew it. That would be this 40, take away this x, take away this x, right? Because when you fold up the bottom tab and the top tab, you're going to lose x and you're going to lose x. So this is going to be 40 minus a couple of x's. And then the long side here, which is this one from here, from here all the way to here, that's what we're talking about, that's the long side. That's going to be 70, take away an x, take away an x as well, so this is 70, take away 2 x's. Okay, so I now have the dimensions, the length, the width, and the height of the box. And I wish to maximize the volume. So here is the function. We can call it the volume function if we want. Instead of f of x, we could call it v of x. And that function is the volume of the box, which would be the dimensions multiplied together. So here we go. There is the function, and I want to find the maximum of this function. Now that is going to be difficult to do without a graphing calculator. So all I'm going to do now is one more piece of the puzzle, and that is to analyze, are there any limitations on x? I mean, which part of the graph are we talking about here? Well, if you look at this here, okay, certainly x has to be a positive number. I mean, you're cutting out a little square that measures x by x. So for sure, x has to be greater than 0. But is there an upper boundary on x? I mean, what's the biggest we could make x? Well, if you look at 40 minus 2x, if x here is 20, then you go, well, that's 40 minus 2 times 20. That's 40 minus 40. Oh gosh, you know, there's no box anymore. I mean, you made x so big, you cut out such big honking squares that the squares are touching. So you basically have no box. So we would have this as our upper boundary, that x cannot be 20 or more. I mean, it's got to be less than 20. Otherwise, It's no longer a box. And that's pretty much all we can say without using graphing software. I suppose we could do maybe one last quick little thing. Nah, actually it's not worth the trouble. So we know that it's going to be the dimension somewhere between 0 and 20, and it's going to maximize this function. And that's where I am going to stop with this example, because as I say, without graphing software, we really can't figure out the actual dimension of x. So we're going to stop there.